As an infrastructure sales professional, delivering total network performance requires the physical wire and active hardware to operate as a single system. If you propose a high-end physical cabling upgrade, but ignore the active network hardware attached to those cables, you put the entire project at risk. Mismatched or under-spec'd routing hardware creates data bottlenecks. The active equipment will choke the data flow, and your client will likely blame the physical cabling you installed for the poor performance. To maintain long-term vendor trust, you have to match the network switch precisely to the client's internal IT capabilities. A successful infrastructure sale depends entirely on aligning the physical capacity of your cabling with the correct active data routing strategy. Network switching is the process of directing data packets between specific devices on a local network. A legacy hub blindly broadcasts identical data packets along all paths simultaneously, creating congestion and wasting bandwidth. In contrast, a modern Layer 2 switch reads a packet's MAC address, intelligently routing it down a single path directly to the correct receiving node. The trade-off is straightforward. Intelligent switches carry slightly higher initial hardware costs, but they drastically reduce unnecessary network traffic. Upgrading a client from a legacy broadcast model to targeted Layer 2 routing is the baseline requirement for modern cabling to reach its full rated bandwidth. When it finally comes time to specify that hardware, there are 3 primary tiers of network switches available for corporate deployment. First are unmanaged switches. These offer simple plug-and-play deployment. You connect them and you get immediate connectivity with zero configuration required. The trade-off for that simplicity is a lack of control. They offer zero security controls, no traffic management, and are difficult to scale. On the opposite end are managed switches, providing full configuration capabilities. Administrators can create virtual LANs, establish tight network segmentation, and monitor traffic with absolute precision. But that level of control comes with steep requirements and a larger budget. They demand a dedicated IT administrative team to manage them and prevent network loops. Sitting right in between them are modern smart switches. These provide access to basic configuration and segmentation through simple web-based interfaces. They act as a practical compromise. You gain more control than unmanaged options provide, but you lack the deep, granular command line capabilities of a fully managed switch. This 3-column matrix compares unmanaged, smart, and managed switches side by side. Looking at security features, configuration complexity, and required IT staffing, you can clearly see how the complexity scales upward across the tiers. Pitching a fully managed switch to a corporate client without an IT staff is selling a machine they cannot drive. This leads to a poor return on investment and damages your relationship. Beyond the physical hardware tier, you must also understand the internal software engine of the switch. This determines how it balances transmission speed against data accuracy. Here is the store and forward technique. A packet enters, pauses entirely to be scanned from front to back, then exits. It guarantees accuracy, but introduces higher latency. Now watch cut-through. The switch forwards data the exact millisecond it reads the destination address. This provides exceptionally fast, low-latency transmission. However, the trade-off is risk. By skipping the full scan, the switch might forward corrupted data packets across the network. A third method is the fragment-free technique, which checks exactly the first 64 bytes of a packet before forwarding it along. This technique acts as a balanced compromise, offering a middle ground of moderate transmission speed combined with moderate error checking. Understanding these software trade-offs helps you justify hardware recommendations based on a client's sensitivity to latency versus their need for data integrity. We map client IT capability on the x-axis against network complexity demand on the y-axis. Small branches with zero IT staff need unmanaged switches in the low-complexity quadrant. Mid-size businesses sit in the middle, requiring smart switches. High-capability enterprise data centers require managed switches. Proposing hardware solutions that land outside of these ideal quadrant mappings introduces operational risk. A complex switch in a low-capability environment leads to catastrophic misconfigurations. Matching the switch tier directly to the client's operational reality prevents network-crippling broadcast storms and glaring security gaps. To apply this framework, you must explicitly assess your client's internal IT staffing levels early in the discovery phase. Ask who will be managing the network on day 2. Frame the hardware discussion around risk mitigation and bandwidth efficiency, rather than getting lost in the technical specifications. Make it clear that the financial value of a premium cabling upgrade is only realized when it is paired with an intelligent Layer 2 routing strategy. Present your final proposal as a single cohesive package, where the physical wire and the active infrastructure are designed to work together. Mastering network switching fundamentals provides the technical oversight required to manage the entire infrastructure package. By aligning active routing with physical cabling, you provide the specialized consulting that builds lasting client partnerships.